All right, boys and girls, did you miss me? I'm going to go ahead and give you the second installment of Final MBT2. The previous video, we just talked about powers of 10. What do they consist of? A base number and an exponent. The exponent tells you how many times to multiply that base number by itself. And if you remember, our pattern that we see from 10 to the first power, 10 to the third power, there's a gradual increase in the number of zeros in our products. So when I check on Monday, I should see what your products are for 10 to the fourth, 10 to the fifth, and 10 to the sixth power. So let's move on over to the right hand side of our journal. And we are multiplying and dividing by the powers of 10. But I'm going to be a little bit more specific with this portion of this video. And I want to say we're going to focus on multiplying and dividing whole numbers by powers of 10. So you may think, oh gosh, now we got to take the base number and the exponent that makes a power of 10. Now we're going to multiply it by a whole number? What is she talking about? Is Dr. Davis going crazy? No, this is math, boys and girls. And we are going to master this standard like no other. If you can see my face and the intensity I have with this standard, you would be amazed. All right, multiplying by the powers of 10, whole numbers. So let's go ahead and do an example. Let's go ahead and make a note. So when multiplying, power. Oh, look, the exponent has another job. The exponent tells you how many zeros you add to your product. Now, first example, multiplying by the powers of 10. Let's go ahead and pull this flat back, and I am going to give you an example. So here's, let me outline this. I just feel like, for some reason, I feel like I should just outline this with my pen. And you, boys and girls, do not use a pen, use a pencil. You know how I feel about my students writing in math, because I've made a couple of mistakes already, but I want it to be colorful, so that's why I chose to use this Sharpie pen. But I have to concentrate when I'm writing because I don't want to make too many mistakes and have to do the video all over again. But mathematicians, you should be using pencils. Don't follow Dr. Davis with the pen, use a pencil. All right. So multiply my powers of 10. So let's say, for instance, we have the whole number, 6. And we're going to multiply that whole number by 10 to the fourth power. Now remember, over to our left-hand side, we were starting to see a pattern with our products. For each power of 10, the exponent related to the number of zeros we had in our product. So if the exponent was 3, our product has 3 zeros, power of 10, 1,000. If the exponent was 2, our product 100 had 2 zeros. So you start to see that pattern over there. I'm messing those up too much. So I have 6 times 10 to the fourth power. Well, here is our power of 10, which is 10 to the fourth power. Remember, it has our exponent, which I'm putting in yellow. Then I'm underlining my base in 10. This right here is our beautiful whole number. This is your whole number. So 6 times 10 to the fourth power, or 6 times the fourth power of 10, it is going to be what do you notice about this product? But you're like, why does she highlight the zeros in 60,000? Oh, because my exponent of 4 told me that I'm going to have 4 zeros in my product. This little guy, this little itty bitty number that's connected to our base number, this exponent, tells me how many zeros to add to that whole number to give me my final answer of 60,000. Mind blown. Just blown. Now, another example. Let's say we have 10 times 10 to the third power. What is that going to be? I'm going to give you guys a minute to think about it. You can pause the video, take your time. Alright, so our whole number right here is 10. All I did was rewrite my whole number. Let me go ahead and get a marker, box in that whole number. Remember I told you Dr. Davis loves to color code stuff because it helps me when I'm working through things in math. That's like my little notes. So my whole number is 10. Let me make an arrow. I rewrote my whole number. Same right here. Now my exponent is going to tell me how many zeros to add to this. That's 3, so I'm going to add 1, 2, 3. So 10 times 10 to the third power is 10,000. And I am going to highlight these 3 zeros because that relates to our exponent, which said, hey, Dr. Davis, make sure you put those 3 zeros at the end of your product. Attach those 3 zeros to your whole number. That's all you're doing when you're multiplying a whole number by a power of 10. That power of 10 and a whole number, they're going to merge together and form your product. One more example. Let's say I have 50 times 10 to the 7th power. So what are we going to do? First, identify what our whole number is, which is 50. So what we're going to do is take that 50 and we're going to write it right here. So now I have 50. Now my exponent is 7. So that means I am going to add 7 zeros to my whole number of 50 to get my product of 500 million. Look at that. Boy, I would love to have that in my bank account. There we go. 7 zeros highlighting yellow. This is my product. Easy peasy lemon squeezy. Did you see did I actually write out 50 times 10 to the 7th power and actually put 10 sevens, multiplied that, and then took that in? No, I didn't do all that. All I did was look at the components of my problem, merge them together, look at my exponent to tell me how many zeros to add in here. And you can even do this. 1, 2, 3, 4. It all relates. 1, 2, 3. Look at there. 1, 2, 3, 4, 5, 6, 7. I know that it's very tiny, but I'm going to zoom in for you guys. I apologize in advance. Because they may get a little smaller as we go on to dividing by the powers of 10. So let's mosey on down to the next example of dividing by powers of 10. Oh, see, made a mistake. You made another mistake. Zoom out. Alright, so with dividing by the powers of 10, we're going to use the same examples up here, All right, so we did 6. Instead of doing multiplication, we are going to do division. So 6 divided by 10 to the 4th power. And I'm going to need some room for this because I'm going to have to rewrite our product or our problem when we are working through it. So let's go ahead. If you have your markers, go ahead and start making or highlight all my exponents. And you know, boys and girls, let's go ahead and make this note right now. Try to find another color pencil. Baby blue. Your operation is very important when you are multiplying and dividing by powers of 10, okay? That is another component that you need to look at, especially when we move into multiplying and dividing decimals by powers of 10. Your exponent and your operational sign is going to tell you exactly which direction to go and how many places to move that decimal point. It's very important. So we have 6 divided by 10 to the 4th power. Now what we have is a whole number, the same thing we had there, and I want you guys to go ahead and take your marker, whatever color you're using to box in your whole numbers, do that for this as well for division. All right? Now, 6 divided by 10 to the 4th power. What we're going to do is, this is where the decimal kind of comes in at, because we can't, when you're multiplying, your product increases. It went from 6 to 60,000. It went from 10 to 10,000. It went to from 50 to 500 million. So when you're multiplying by a power of 10, your product is going to increase from the original whole number that you're working with. So like I had 6 as my whole number here, and I multiply it by 10 to the 4th power, which is also 10,000. What I did was my value went from 6, it increased because I multiplied, it went from 6 to 60,000. I multiplied, it went from 10 to 10,000 when I multiplied by 10 to the 3rd power. My whole number of 50, when I multiplied that by 10 to the 7th power, it went from 50 to 500 million. So because we're dividing, my answer, my quotient should decrease. I should have a smaller amount than what I started with in my original whole number. So I'm going to write the number 6 right here. Now, because I am decreasing, my whole number right now is 6. So my ending number, my quotient is going to be a decimal. Now, where's that decimal point? You don't see a decimal point up here, do you? No, you do not. I didn't put a decimal point there. But you should take, for what you've learned in previous grades, that when you have the whole number, which is clearly in the ones place right here, this is the ones place value. The decimal point is to the right of that ones place value. Because my exponent is 4, this exponent is telling me, hey, Dr. Davis, you're going to move this decimal point 4 places to the left. Why are we going to the left? Well, if I go to the right, it's going to increase my value. When I go to the left, that means I'm dividing. I'm showing that my value is decreasing from the whole number of 6. So 1, 2, 3, 4. 4 humps, or like dips. Let's call them dips because we're going down. We're dipping. We're dipping down. I have 4 dips. 1 dip, 2 dip, 3 dip, 4 dips. And you're probably thinking, now what is she going to do with all these dips? Because now she has a new home for her place value. It is no longer this. My new place value is over here to the left. I am going to fill those dips with zeros. So now I'm going to take this new value, and see, I marked out that decimal point because I moved it from the right side of the ones place value, all the way over to the left hand side. So my value, when I take the whole number 6 and divide it by 10 to the 4th power, which is also 10,000, my new value is, see, tenths, hundreds, thousands, 10,000. So my new value is 6 10,000, because the 6 is in the 10,000s place value. So this is now my new answer. So let's go ahead and do it again with 10 divided by 10 to the 3rd power. I'm going to write my whole number of 10 right here. Now the 0 is in the ones place value, so my decimal point, we have to move it. So because my exponent is showing 3, I'm going to have how many dips? 1, 2, 3. That is my new home from my decimal point. And I am going to fill this other hump right here with a 0. Because the 0 is showing that there is still no value in that place, but I didn't want to have this huge gap in between the 1 and the decimal point, so I can fill it with a 0 to show that there's no difference in the value right here. It's still 0. I just put a 0 right there too, so there won't be an empty space. So 10 divided by 10 to the 3rd power is going to be tenths, hundreds, so it's going to be 10 hundredths, or 10 thousandths, actually. Tenths, hundreds, thousands, so it's going to be 10 thousandths. So it went from 10 to 10 thousandths. Now the next one, 50 divided by 10 to the 7th power. So I have my whole number of 50. I probably should have brought it over to the right a little bit more. I'm going to take my decimal point because that 0 is in the ones place value. Remember, my decimal point is on the right-hand side of the ones place value. Now I'm going to make my dips. 1, 2. How many dips am I going to make? 7. 1, 2, 3, 4, 5, 6, 7. All right, so I'm going to fill these dips with zeros. So this is my quotient. And the reason why I'm saying quotient, because in my problem, I have an operational sign division. So I am dividing. So 50 divided by 10 to the 7th power. I made my 7 dips. What you can do, if you want, if I had a different colored pen, which I can't believe I didn't. Well, I have this one right here. You can actually write the number of dips. So this is 1 dip, 2 dips, 3 dips, 4 dips, 5 dips, 6 dips, 7 dips. Right here, we did 1 dip, 2 dips, 3 dips. That matches with our exponent. Here I did, oops, well, I kind of can't write. 1 dip, 2 dips, 3 dips, 4 dips. That matches with my exponent. So the exponent in this case, when you're dividing a whole number by power of 10, the exponent is telling you how many place values to move your decimal point. So because my exponent is 4, 1, 2, 3, 4. Because my exponent is 3, 1, 2, 3. Because my exponent is 7, 1, 2, 3, 4, 5, 6, 7. And then I fill those empty spaces with zeros because that does not change the value that I have when I divided a whole number by that power of 10. So the note that we made up top, when multiplying a number by a power of 10, the exponent tells you how many zeros you add. Add, 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 add. Now here's another note that I like to let my students remember because it's a good point. When you multiply, your value goes up. And then when you divide, your value goes down. Important note. Importante. Important note. That means remember this. So when you are working with 5-MBT2 and you are multiplying or dividing by a power of 10, you say, okay, here's my problem. 6 times 10 to the 4th power. Ooh, I'm multiplying. So my product should be larger than the whole number that I am starting with in my problem. So if I'm multiplying 6 by 10 to the 4th power, my answer should not be 600s, because that means I divided, and that would not be correct. You're multiplying. So my answer, see how I went from a whole number of 6 to 60,000, a whole number of 10 to 10,000, a whole number of 50 to 500 million. Boom, bing, bam. Same thing right here. I'm dividing those same whole numbers by the same powers of 10, but the only difference is I am dividing. So my value, my quotient is going to be smaller in value compared to when I multiplied by a power of 10. So that is it for 5-MBT2 on the second video. We're multiplying and dividing whole numbers by powers of 10. Now, when you guys go to work on the multiplying and dividing decimals by powers of 10, same concept, but we already have the decimal points in our problems. You know, in dividing, we had to place a decimal point right behind the ones place value in our whole number so that we can be able to have something to move to show that the value is decreasing because we're dividing. When you're multiplying a decimal by power of 10, that's going to be the next video, and it's building up off of this. So make sure you've mastered, at least try to memorize the powers of 10 for exponents 1 through 6. That is going to, try to memorize and master what the products are for the powers of 10 for the exponents 10 to the first power all the way through 10 to the sixth power. You should be able to say, hey, Dr. Davis, I know that the 10 to the 4th power is actually what? 10,000. Dr. Davis, I know that 10 to the 2nd power is actually what? 100. It's going to come at the top of your head like clockwork. You'll be able to spit it out to me as fast as you can. So if there are any questions, please make sure you make notes in your journal, and you can dojo me or you can ask them when you come to class on Monday, but make sure this is filled out and all of this is written in your journal by Monday morning. So you can take any day this weekend to work on it, get it done, no problem. Hope you have a good weekend, and I will see you all on Monday. All right, bye.